I am Nathaniel, and today we will now be doing A-level mathematics. Today we will now go through the topic of trigonometry. The textbook I am using is by Linsky, Nicholson and Weston and is made by the Oxford University Press. Trigonometry. The name, just the name of it, made people think it's actually a daunting subject. But no, it is not. Contrary to popular thought, it is really a very easy subject. Actually, maybe not easy, but it's not as hard as it seems. But to start, you need a strong visual foundation of probably transformations and the unit circle, which we'll cover. So this is the unit circle. Again, it will be very difficult to express this in words, so let's use this Desmos Interactive. I'll put the Desmos Interactive in the description. So basically, this unit circle has a horizontal line of cos t, a vertical line of sine t, and then the t is 1.047. The t is a replacement for theta because I can't print theta in Desmos. Okay? Good. Let's talk about graphs of trig functions. So if you play around the unit circle a bit, you will know what's sine and what's cos, and if you try plotting it out, it will look like this. The tangent is basically sine over cosine. I wonder why they name it tangent in the first place, because it's just sine over cosine. So on the graphs, you can just see some relationships between them written in degrees. Here are these for sine, for cos, and for tan. As you can see, sine negative x is negative sine x and tan negative x is negative tan x simply means that these are called odd functions and cos x is an even function. And if you look at these, you will realize that sine and cos have period 360 and tangent has period 180, all in radians, 2 pi and pi respectively. Again, you can write these down in degrees and radians so that you will know, because in A-level mathematics, you will be expected to know both degrees and radians. Let's talk about inverse trig functions. Just as the name suggests, these are the inverses of normal trig functions. So sine 1 is 0.8414, sine inverse 0.8414 is 1. You can try this on a calculator. Or if your calculator is a bit old-fashioned, you might see a sine or arc sine, but whatever, they mean the same thing. This makes me wonder who designed these notations. Composite graphs. So sine x, cos x, tan x, what you see in common, they look like functions. If you place f by sine, cos, tan, it will have the same look. So you could see sine x could be the fx and apply the relevant transformations. So let's try a very difficult but easy example. The reason why I say it's a bit easy is because you have covered this topic before in functions and transformations. Pause the video if you want to figure out the transformations of sine x on your own. Did you get it yet? Well, here are the transformations. Stretch by a factor of 115 on the x-axis and 4 on the y-axis. And the translation by negative pi over 4, 7. Trig Identities, tan theta is sine theta over cos theta, and sine squared plus cos squared is 1. Pythagoras theorem on the unit circle. Which makes you wonder, why do they name it as tangent and not sine over cosine? Because, you know, so ka toa. You could just take away toa. Well, maybe tangent might be useful for some of you who want to survey ground and you deserve an operation for it. So tangent users, well done. You deserve an operation for tangent. Mathematicians included. Because so ka toa, because OA opposite over adjacent is basically opposite over hypotenuse over adjacent over hypotenuse, which is sine over cos. Therefore, proving tangent theta is sine theta over cos theta. And the sine squared plus cos squared equals to 1 is just Pythagoras theorem on the unit circle. As I said before, you can play with the unit circle interactive and try proving this theorem on your own. Thank you, and see you in my next A-level mathematics video.